Okay. Good afternoon, ladies and gentlemen. And first of all, thank you for the opportunity to present OmicsDI here. So I think I don't really need to introduce the FAIR concept, which has been mentioned a couple of times here today. So OmicsDI is about finding omics datasets. And we all know finding literature in PubMed, EuroPMC is fairly straightforward. Assuming you can phrase your query correctly, you can assume that you will get the relevant results. For omics data, it's not the case. Although the different communities have made a lot of progress in the last years to get together within each community, there's no proteomics change where the proteomics repositories work together, metabolomics change where the metabolomics repositories work together. But you still have lots of different entry points if you really want to get an overview of all the available omics data sets of interest to you. And so what we wanted to achieve with OmicsDI is really to develop a kind of PubMed for omics datasets. And this is accessible at omicsdi.org and has recently been published a couple of months ago now. And the concept is that we build on the information provided by the individual repositories. Each of the repositories provides a short summary of the metadata, only the metadata of their data sets. So we're not trying to copy all the data sets into one place, only the metadata, which is then in a fairly standard architecture, indexed by a Lucene-based indexing system. Then everything provided by this indexing system is accessible via web services. So everything is also accessible via web services to third parties. And then this is what we build our web interface on. And this builds on technology which at the EBI is indexing now 1.5 billion entries. So we are fairly confident that it will scale. We are using a fairly straightforward approach for the metadata. We all know that it's hard to get metadata, to get enough metadata, to get the right metadata. We are very practical in the approach. We have defined a couple of mandatory fields, desired fields, and additional fields. The additional fields are mainly for the domain-specific areas, like if you are having a metabolomics data set, you're not interested in proteins, but you are very much interested in these if you have a proteomics data set. And we have also, in the BD2K collaboration, mapped our metadata schema to that. So there's a compatibility between the two major approaches there. And based on validated metadata sets, we are then providing OmicsDI. We provide a graphical interface for browsing, for the usual features like auto-completion, faceted search. And once you have defined your query, then you get a list of the resulting data sets which correspond to your query. And these are marked up, as I mentioned, with facets for further refinement, but also you have a nice visual typing of the different omics data types, proteomics, metabolomics, transcriptomics, genomics, and multi-omics. So we use the publication as the common denominator. And therefore, even if you had to split up your data in a large multi-omics study across multiple repositories, because repositories tend to be specialized for one specific data type, in OmicsDI, you will see all of these, and you will see all of them listed, so you can again see this was actually a multi-omics study, and we are currently refining how we are representing this in a more hierarchical way, but we are really for the first time bringing these multiple independent submissions together again with the publication as the reference system. Then, if you zoom in on one specific data set, then we also want to provide the same functionality, which you have, for example, from PubMed, which is you are looking at this data set now, but you might also want to see these others, or if you're in Amazon, you might also want to buy this other thing. And we show, based on the usual Solr functionality, we provide related data sets. So this relationship type is based purely on the metadata similarity, but I'll come back to other types of similarity, which we are also analyzing. But first of all, it was already mentioned, fair data not only implies, or the interest currently is not only about findable, interoperable, accessible, reusable, but also, especially given that there's probably a number of funders in the room, metrics. So is data actually useful? And so we are also capturing not only what are the latest data sets. So this is actually a screenshot from today. So the last data sets were added on Friday. Apparently nobody works on Saturday, Sunday, strange. And we also provide, this is only within OmicsDI at the moment, we provide the access metrics. So what are the most accessed data sets where people have clicked on within OmicsDI, which of course is not a complete metric, and we might look into how we can extend this to a better coverage in the future, but it's at least a beginning within this system. Currently, we are indexing 15 resources, a bit more than 90,000 data sets from 4 continents. One of the latest additions is the links data set from the BD2K context. And one of the things we also want to trace increasingly is data reuse. So we are collecting the data already because we get it from the providers, in some cases at least, where a data set provider tells us this data set was reanalyzed in this other context. So this comes from the repositories. And so we are showing not only where to get to the actual data, but also this data set has been reanalyzed, and this is this other data set which resulted from the reanalysis, which can be fairly complex, like in this proteomics case where one data set resulted in lots and lots of reanalysis. In this case, it was because different tissues from the parent publication were then resulting in different sub-analysis for each of the tissues in the reuse. But so we are starting to build up really a tree, an inheritance tree of where data has originated, who has reused it. And so we are starting to contribute again, not only to trace reusability, but also actual reuse, and to really track what is actually being done with the data. Coming back a bit to the findability, this is all within OmicsDI, but we are also starting to look into making the data findable within other contexts, and we are starting to mark up our data with schema.org, which allows then to, in the future, hopefully find the data better in Google, but also schema.org is, although it's proposed by Google and other large indexing-oriented companies, it will also help us within the community to harvest metadata on a large scale in a systematic way, and to make this accessible in many other contexts. And there's a lot of work going on in extending the general schema.org now towards life sciences in the Bioschemas initiative, which is driven a lot in Elixir, but also is really pursued on both sides of the pond. And this is what it looks in practice, where through the Google test tool, you can then see the markup, which is included in the actual web page. Another aspect, and this is for the first time that I'm talking about it, is credit attribution. So when you submit a data set, usually there's one submitter, John Doe, who has actually done the submission of this data set, but there's probably many more people who have contributed to generating the data set. Most of them, or all of them, should be listed on the publication. But we are discussing a lot about making data a kind of first-class citizen in its own right, rather than being entirely dependent on the publication which is associated with the data set. And so we have also added as the latest feature the capability to register within OmicsDI with one of the standard mechanisms. Currently there's one authentication scheme which in itself spans several based on Elixir. You can use one of your standard social network logins, or probably the most important one in the scientific context, ORCIDs. And so you can sign in with your ORCID account. And then you can create your own profile, which has the usual short description, but then you can claim data sets to which you have contributed across everything that you find in OmicsDI. So not only in one repository, but in all the 15 we have now, and potentially more we might have in the future. And you can say, I have contributed to this data set, I want to claim this to my profile, and then you can put the link to your profile into your CV. Now this is a first step, but it is an island solution. So the next step is that we will allow people to propagate these claims back to their ORCID login, so that you then can see the claimed data sets on your ORCID profile, and you make it really visible together with many other scientific outputs. These are the data sets I have contributed to. So far, most of what I've talked about is either in production or, actually no, this is one more step, is linking between multiple omics data types. So far, what we are doing is we are building to link between different between different data sets. We are building on the link of the publication. So if multiple data sets share the same publication, then we can establish the link. In the future, we'll probably also start to look into linking by the actual claims, if that is a feature which is taken up well. But we've also, so far for proteomics, started to go a bit deeper. And we are asking now the repositories not only to provide the typical metadata, but also in the case of proteomics to provide lists of the identified proteins, for genomics to provide lists of the significantly regulated genes. And then we can start generating graphs like this. So for one proteomics experiment, you get a nice diagram which shows you what are the most related experimental data sets to yours by the actual data content, by the list of identified proteins, or by the list of regulated genes. And this is a completely orthogonal way of determining similarity between data sets, which we are showing where we have the data in addition. And we call this the biological similarity. And this works already within within each omics data type. And we are working on implementing this deeper. For the future, and this is still pure research, everything I've talked about so far is either already on the production server or it's on the dev server. Where we are still at a much earlier stage is with this idea of linking between different data types through things like pathways or systems biology models, which are concerned not only with one type of molecules, but pathways put small molecules, chemical entities, and proteins, genes into the same context. So we hope that we can extend this feature of biological similarity really across multiple data types and really build potentially non-obvious connections between different data sets and experiments. So this is really the main perspective for the future. And with that, I would like to acknowledge the team. The OmicsDI project has been led by Josep Perez-Riverol, with in the development team Ming Zabai, Gauhari Das, and Andrei Zorin. We have had lots and lots of contributions from many different data providers who have helped us a lot. And of course, most thanks are due to the NIH for allowing us to play with the big boys in the BD2K context. And so for the funding, thanks to Peipei Ping for involving us. And with that, I would just like to make a brief plug for the other activity we have been doing in BD2K, which has dealt with enhancing visualization of biomolecular pathways in Reactome. And there's a poster B229 tomorrow. And one of the things we did is, in this project, we drew a lot of diagrams. And these are SVGs, which you can really edit. And we decided, well, these have reusable components. We have many cell types, receptors, whatever, which occur on many diagrams. So we don't want to redraw them all the time. We put them in a separate library. And that library is now also publicly available. So even if you're not interested in pathways, you might very well be interested in a large library of visual elements which you can use in your PowerPoints, your illustrations, your grant proposals, whatever. And so that's the neighboring poster 231. Thank you. Questions?
Thank you for a great talk, and I apologize if this is a naive question, but you will think that sort of anybody working in a specific disorder will really want to go and plug the disorder and bring back all their omics data sets. So how exactly do you map the data sets to the disorders? Is just that based on the text, or you can imagine pulling out a lot of data sets that won't be relevant, right? How you control for that in your search?
Sorry, you mean going to the name, or?
So if a researcher wants to study a disorder and pull out all the omic data sets through the disorder,
yes,
right? Which is an obvious great application of your tool. How exactly do you map the search to make sure that you really are pulling out relevant data sets and not things that just got annotated with that name that are not relevant at all?
So we can't do much about the false positives in the same way that you get, when you do a PubMed search, you get lots and lots of irrelevant publications. And we, at the moment at least, don't have any idea how to get rid of these. We can't help you there. I think the emphasis is more on getting as much of the data sets as possible, and then you have to do the filtering yourself. One feature which is on our to-do list is, again, what is already in PubMed, which is just click on these data sets and save them to the Notepad or Scratchpad and download them, save them to your account or whatever. So that is one of the next features we plan to implement. But that's really the only thing we can do. Otherwise, you have to just refine your query. The other thing, what I didn't mention here, is we are actually using Mark's tools. So we use the NCBO tools to make the whole system ontology aware. But again, this is more for broadening the search to make sure that we get all the different variants of H, which Mark mentioned, rather than narrowing down and avoiding false positives.
Thank you.
Could I add a comment to that? Actually, it's an excellent question. It goes back to the question Dr. Mark Newson and I were discussing. So if at the moment you're looking for a clinical omics data set, that was your question with the disease phenotype, there's no simple search. The most collection, the public de-identified data sets are all in dbGaP. that data sets, many of them are still secure firewall. And also, there's no link. There's the first process of metadata of all these data sets. Then we can build a search engine to identify based on these things. Sounds very simple, but we're not there.